Example 25. Write a single radical expression for this quotient. So, we're given this quotient, we need to convert this quotient to one single radical expression. Okay, solution. So we start with x raised to 5 divided by 6 times y raised to 3 divided by 8 divided by x raised to 4 divided by 9 times y raised to 1 divided by 4. Okay. Now I can rewriting this as x raised to 5 divided by 6 over x raised to 4 divided by 9. My goal is to grouping all the x together as one quotient time another quotient that group all the y together. So this second quotient would have only y, which is y 3 divided by 8 times y raised to 1 divided by 4. Okay, so given with one quotient, I just split and make it into two quotients. The first quotient only involves x. The second quotient only involves y. Alright, now we have this. We're going to use the rule a raised to negative m is equal to 1 divided by a to the n power. Okay, now we have this in the denominator. Okay, a to the n, we can write this in the numerator that has no fraction. The only thing changed is that instead of having the positive exponent, now you have negative exponent. Okay, for the x in the denominator, so the x in the this x 5 over 6, you can rewrite this as 5. So x raised to 5 or 6 times 1 divided by x raised to 4 divided by 9. Okay, so this one quotient, I'm just splitting it, okay, into x raised to 5 divided by 6 times 1 divided by x raised to 4 divided by 9 times, I'm going to do the same thing. I'm going to have this y in the numerator go here, 3 divided by 8 times this y in denominator, and I'm going to split it to here, which is y raised to 1 divided by 4. Okay? The reason I want to split because I want to have this form for this exponent in the denominator. Once I have this, I can use this formula. Okay? That's why I split this quotient into two factors, and I factor this quotient into two factors. Okay? Now, I'm going to use this formula to rewriting this exponent expression in the denominator to this in the numerator. Alright, so we have this one stay the same as x raised to 5 divided by 6. Now for this, okay, you can convert this to x raised to negative 4 divided by 9. Okay? So I'm converting this quotient into this using this formula. Okay? So for this we have y raised to 3 by 8 stay the same as is. Now for this, I can use this formula to convert this to y raised to negative 1 divided by 4. Okay? Now we have four factors, right? 1, 2, 3, 4. So let me be writing all the factors we have here. X 5 to the 6 times x raised to negative 4 divided by 9 times y raised to 3 divided by 8 times y raised to negative 1 divided by 4. Okay. Now, if you look at the first two factors, they have the same base, x. Okay? That means you can combine those two factors, let me see, using the laws of exponents. So if you have the same base right here, xx, for example, the laws of exponents, a times m times a n, same base a, right? When you multiply them, you can take the sum, which is m plus n. Okay. Now you have a, m, but this time you have negative exponent. So same base, this has positive exponent, this has negative exponents. If that can happen, you have same base, right? You can write it as one base a, take the sum of these, which is a, which is m minus n. Okay? If you have negative here, that means you take the difference of the two, m minus n. Or think about taking the sum of this m plus negative n, m plus negative n, right? It's simplified to m subtract n, which is here. So I'm going to use the laws of exponent to simplify these two factors and these two factors. Okay? Alright, same base. I'm going to combine this as one base, x, and taking the difference of 5 over 6 subtracts 4 over 9. Okay? And for this, d2 factor has same base, right? You can use the laws of exponents here. So combine from two same base y to one base y, and then take the difference of these two exponents, 3 over a subtracts 1 over 4. Okay? Now, because this is a fraction, right? 5 over 6 subtract 4 over 9, you can simplify that to one fraction. So combine these two. This is 6 is the denominator is 2 times 3 in prime factor form. 9 in prime factor form is 3 squared. Okay, 3 times 3 is 9. Now the LCM is, again, you use the factors from denominators with the great number of times that factor occurs. So for 2, it's only happened one time, right? Because 2 raised the first power, so only 1 for 2. And for 3, this 3 only happened one time, right? Because 3 raised the first power. Now, but this 3 right here happened 2 times because its exponent is 2. So I'm going to use 2, 3 squared. Simplify, get 2 times 9, which is 18. So I'm going to convert this 6 and 9 to 18, okay? Because LCD is equal to LCM, which is 18 here is 18. So LCD is 18. So I'll convert each fractions with the same denominator, LCD 18. Okay. So 5 over 6 converts to the one that with the LCD 18. That means I will multiply by 3 at the bottom because 6 times 3 is 18. Okay. Now, if I divide by 3, I have to multiply by 3, so that won't change this 5 over 6 fraction. Now subtract here 4 over 9. Again, I want to convert this second fraction to the form that has denominator LCD 18. So 9 times what is equal to 8? Is equal to 18 times 2, right? 9 times 2 is 18. Once I divide by 2, I need to multiply by 2 so that I won't change this second fraction, 4 over 9. Now simplify, I get 5 times 3 is 15. 6 times 3 is 18. Subtract 4 times 2 is 8. Divide by 9 times 2 is 18. Now, once I have two fractions with the same denominator, I can combine them. That's one denominator, 18. 15 minus 8. So 15 minus 8 is, let's see, 15 minus 8 is 7. 7 over 18. Okay? And this you cannot simplify any further. So I'm going to replace this difference between these two fractions which is here, 5 over 6 subtract 4 over 9 with this simplified form, which is 7 divided by 18. Okay? So, x, we play the whole thing here with 7 over 18. Okay? Now I need to combine these two fractions as well. So I have 3 by 8 subtract 1 over 4. Okay. So this denominator is 2 to the third power, because 2 times 2 is 4, 4 times 2 is 8. So 2 raised to the third power. For this 4 is 2 squared. Okay. The LCD equal to LCM, and the LCM is the number, the products, LCM, the products of all the factors from denominators, where each factor you use the factor with the greatest number of times that it occurred. So look like you only have 2, right? This 2 happened 3 times because it's raised to the third power. So I'm going to use this 2 to the third power for the LCM because it's happened with the greatest number of times, 3 times, and it beat this one, which is 2 times. So simplify, I get 8. So I know that the LCD is 8. That means I need to convert these two fractions with the same denominator, LCD. Now for the first fraction, it's 3 by 8. And 8 is already the LCD, right? So I don't need to modify anything for this first fraction. So I will leave it as is. For this second fraction, the denominator is 4, right? So it's not 8 yet. So I need to convert this 4 to 8. To do that, I multiply by 2 at the bottom because 4 times 2 is 8. If I do that, I need to also times 2 on top so that I won't change this fraction 1 over 4. Then simplify. 3 by 8. Subtract 1 times 2 is 2. 4 times 2 is 8. These two fractions have the same denominator 8. I can simplify to one fraction 8 as denominator. 3 minus 2. Simplify, I get 1 over 8. Okay. Now I'll replace 3 over 8 subtract 1 over 4, which is this, with this. Okay. Time y raised to 1 over 8. Okay. Now, we're not there yet. We need to write this to one single radical expression. So, we have these two exponent expression. To combine these two, okay, we need the factors, we need the exponent of each base. This exponent here and this exponent here must have the same denominator. So we have 7 over 18 and we have 1 over 8. We need the exponent here and the exponent here must have the same denominator. For now, they are different. 1 is 18, 1 is 8. So we need to convert these two fractions with the same denominator, LCD. So the first one we have is 18. 18 comes from 2 times 3 squared, okay? Because 9 times 2 is 18. For 8, it comes from 2 to the third power. Because 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8, okay? Now for the LCM, is the products of all factors from the denominators, okay? But you use the factor with the greatest time, the greatest number of times it happened. So for 2, it's only happened 1 time here, right? Because it's raised the first power. But this 2 right here, it happened 3 times. So I will use 2 raised to the third power for the LCM. Now, I also have 3 as the factor, right? This 3 happened 2 times because it's 3 raised to the second power. So I'm going to use 3 squared because I know 3 here. This 3 right here is happened 2 times because this exponent is 2. Simplify, I get 2 to the third power is 8 times 3 squared is 9. So the LCM is 72. Now, LCD equal to LCM, which equal to 72. So that means we need to convert these two fractions to the equivalent form that has 72, the LCD 72, as a denominator. Okay? So 7 divided by 18. Now 18 times what equals to 72. Okay, so 18 times what equals 72. Alright, as you see, the LCM, which is 72, right? Which is here, 72. 72, when you factor out, it's come from 2 to the third power times 3 to the square, right? For 18, let's see. Let me write here. So LCD is equal to 72, which comes from 2 to the third power times 3 square, right? So this is LCD. For 18, okay, 18 has 2, 1, 2, and 3, 1, 2, and 2, 3, okay? If you compare this with the LCD and try to find the missing factors, for this 2, right, and this 2 right here in the LCD, you only have 1, right? 1, 2 for the 18, but you have 3, 2 for the LCD. So that means I need to multiply by 2 squared because I'm missing 2 of them, okay? Compared to 2 with the LCD right here, I know that I missed out 2 because what I got is only 2. LCD is 2 to the third power. How about the 3 compared with the LCD here? Okay, 3 squared, 3 squared. They're the same, right? So you don't have to include. So you include the factor that you miss out. So 2 squared is 4. So that means you need to multiply 2 squared on top as well, so that you won't change this original fraction 7 divided by 18. Simplify, you get 4 times 7 is 28 divided by 72. Okay? Again, 4 times 18 is 72. Okay? That's what we want. We want to convert this fractions to an equivalent form that has 72 as the denominator, and 72 is the LCD. Okay? So this x right here, I'll replace 7 divided by 18 with this. So 28 divided by 72. Okay? We need to work on this as well for the y. So for the y, its exponent is 1 divided by a. So you got to think about a times what is equal to 72, which is LCD, right? Got to multiply by 9, right? Because a times 9 is 72. To do that, you have to multiply 9 on top so that we won't change this original fraction. Simplify, we got 1 times 9 is 9, a times 9 is 72. So I'll replace this exponent 1 over 8 with 9 over 72. So time y raised to 1 over 8, which is this, 9 over 72. Okay? Let me make state. Once we have two factors with exponents that have same denominator, which is 72 here, we can combine e2 to one factor with common outer exponents using the laws of exponents. An, you combine the two, you have a to raise to the n power, right? Time b raised to the n power. You can combine this as and you have a raised to the n power and b raised to the n power. You can combine them as a times b, and these common factors go here, m. Okay? So we have 72, right, as the common factor. So I'll have x raised to 28 state, and then y raised to the 9 state. The one I'm going to factor is